Welcome to a Sim Code. If you want more great tutorials like this one, don't forget to like and subscribe. A hash table in C is a data structure that stores key-value pairs, where each key is mapped to a specific index in an array using a hash function. The hash function takes the key, often a string, and computes a hash value, which is then mapped to an index in the table. This allows for efficient retrieval of values by their keys. However, collisions can occur when multiple keys hash to the same index, which is typically handled using techniques like chaining, linked lists, or open addressing. In C, a hash table is usually implemented as an array of pointers, where each index points to a linked list of nodes, each containing a key-value pair. This structure allows for fast insertion, deletion, and lookup operations on average, making it a powerful tool for implementing associative arrays or dictionaries. Standard library to handle input, output functions like printf. Standard library for memory allocation functions like malloc and free. Standard library for string manipulation functions like strcpy, strdup, strcmp. Define the size of the hash table, number of buckets. 10 is small, but good for demonstration. Node structure that represents an individual key-value pair in the hash table. Each node can potentially point to another node, chaining if there is a collision. This is the key for our key-value pair, stored as a string, char array. The value associated with the key. Pointer to the next node in case of a hash collision, when two keys hash to the same bucket. The actual hash table data structure. It's essentially an array of pointers to nodes. Array of size table underscore size. Each index can hold a linked list of nodes in case of collision. Hash function converts a string, key, to an integer value that maps to an index in the table. It uses a common hashing technique where we accumulate the value of each character and mix bits for randomness. Initialize hash value to 0 will accumulate the hashed value here. Loop through each character of the key, string, and update the hash value. We are essentially mixing the hash value with the ASCII values of each character to generate a unique integer. Left shift by 5 and add current character's ASCII value. The bit shift operation helps spread out the hash value and introduces more randomness. Now, we use modulo table underscore size to map the hash value into the range of our table size. Ensures that the value fits in the array indices. Create node function. This function creates a new node that holds a key value pair. Allocate memory for the new node dynamically. Copy the string key into newly allocated memory, so we own it. Set the value for the key value pair. Initialize the next pointer to null because it's the only node in the list at this point. Return the new node. Create hash table function initializes a hash table with all buckets set to null. This function creates a new hash table object and sets up all the array slots to null initially empty. Allocate memory for the table. Initialize all slots in the table, array of nodes, to null, meaning each bucket is empty. Return the pointer to the created hash table. Insert function. This function inserts a new key value pair into the hash table. If the key already exists, it updates the value. Otherwise, it appends the new key value pair. Use the hash function to determine the index where the key should go. Create a new node with the given key value pair. If the bucket is empty, null, we can directly insert the new node there. Place the new node at the index. Collision handling. There's already a node at this bucket, so we need to handle the collision. Traverse the linked list at the bucket. Check if the key already exists in the list, and update its value if so. Compare current node's key with the new key. Update value if the keys match. Free the key memory of the new node. We won't use it anymore. Free the memory for the new node since we updated the existing one. Exit the function as the key value pair was updated. Move to the next node in the list. If the key wasn't found, append the new node to the linked list. Point the new node to the first node in the list. Update the bucket to point to the new node. Get function retrieves the value associated with the given key from the hash table. It returns -1 if the key does not exist in the table. Find the index for the given key using the hash function. Get the linked list at this bucket index. Traverse the list at the computed index to find the key. If the key is found, return the associated value. Return the value if keys match. Move to the next node in the linked list. If we reach here, the key was not found in the table. Output a friendly message. Return an error value, -1, to indicate the key was not found. Delete function deletes a key value pair from the hash table. Find the index for the key to delete. Start traversing the linked list at this index. Keep track of the previous node so we can unlink the node to be deleted. Traverse the list at the index to find the key. If the key is found, delete the node. If the node to delete is the first one in the list, update the bucket to point to the next node. Otherwise, unlink the node by setting the previous Nodia Euro S next pointer to the current Nodia Euro S next. Free the memory for the key string. Free the memory for the node itself. Exit the function after deleting the node. Move the previous pointer to the current node. Move to the next node in the list. Output a friendly message if the key was not found. Print hash table function prints the contents of the hash table for debugging or visualization. Loop through each bucket index in the hash table. Get the linked list at this bucket. If the bucket is not empty, print the contents. Traverse the list and print all nodes in this bucket. Print the key value pair. Move to the next node. Main function to test the hash table functionality. Create an empty hash table. Insert some key value pairs into the hash table. Print the current contents of the hash table. Retrieve values by key. Delete a key value pair. Now run our code. That's all for today. Be sure to like, comment, and subscribe for more.